Okay, for a little piece of 2.6, I decided that rather than addressing distance learning while I did the live class, because there's some technology pieces that I'd like to share, I decided to film this one separately so I didn't have to kind of just deal with the complexity of having multiple display methods. So anyway, what I'd like to do right now is take a look at a couple of rational expressions for the first time. Sorry, the music's going to go now. Where the numerator is actually larger than the denominator. So I have three quick examples, F, G, and H, where notice that I have a second degree divided by a first degree, I have a third divided by a first, and then finally a fourth divided by a first. They can actually be different than this. They're just, these are simple examples. So I'm going to start by just doing a quick division using synthetic division. Very sorry that the music decided to kick off right as I'm doing this. But here we go. So I'm going to go through this process that we have, and I'm going to write a summary statement. So in the same way, gosh, I hate the music. Back in elementary school, if you said something like how 12/5 was 2 2/5, what we could say is this divided in perfectly to negative 3x plus 9 plus 16 as a remainder over x minus 1. Now, what is significant to me about this, when we start dealing with what's called end behavior asymptotes, we're actually discussing then what happens as x approaches infinity. And, you know, in comparison to infinity, some of these things are not all that important. Like 9 isn't compared to 3x as being all that important. But as x goes to infinity, this piece right here, as x goes to infinity, basically goes down to 0 pretty rapidly, because 16 divided by any large number is going to get smaller and smaller, and as x gets bigger, it's going to become less and less significant. This 9 is going to remain. So let's just see what happens if we take a look at just negative 3x plus 9. So let me go ahead and switch over. Unfortunately, my thing hijacked over to the other side. So let's take a look at a quick Desmos right here. Now I actually have x equals 1. That's a nice little vertical asymptote. I have negative 3x plus 9. That's what's going to be called our slant or oblique end behavior asymptote. And so ultimately my graph should want to get close to both of these numbers. And of course, if I hit and I turn it on, what you can see is the graph does in fact get close. And the further that you are out to the sides as you go to infinity, the closer and closer it gets. Now, as a side note, if I added back in, so keep in mind what this looks like, if I added that remainder back in, interestingly enough, plus 16 over x minus 1, I actually get the original problem back. So the nice thing is if you delete the remainder, that's actually what gives you that end behavior asymptote. And quite clearly, it's very close on the sides. So let's go ahead and turn those off, and let's take a look at the second question. So my second question is looking at 2x cubed plus x plus 4 over x plus 2. So let's get back over to the share screen. Unfortunately, it keeps wanting to go to the other one. Now, in this case, if we have a cubic divided by a first degree, a third degree divided by a first degree should be a second degree. And so I'm going to go ahead and do that again. And just like the last problem, I'm going to throw away the remainder, because that remainder, just like this one, is going to go to 0. Now, I did hook a couple people earlier today. They didn't realize that that 0 is there. It's a little bit sneaky. 2 times negative 2 is negative 4. We multiply, we get 8 and 9. Again, not going to worry about that. But the fact that we have a third divided by a first means this is a second, which means my end behavior asymptote should be 2x squared minus 4x plus 9. So let's go ahead and see what we can do if we look back at Desmos. And let's see. So I definitely had a vertical asymptote at x equals negative 2. I definitely had this weird parabolic asymptote that I got when I throw away the remainder, and here comes my actual graph. And it's a little subtle with all that, but this is what the actual graph looks like if we were just looking at it. And if you could cover up that part in the middle with your finger or something, it would totally look like a simple parabola. But there's the vertical asymptote, obviously really matches. And then when I throw that asymptote in, you can see that green thing really models the curve to the point where you could literally just about throw away the original thing and just do the green one. And on the sides, they're just so close to the same thing, it's ridiculous. So that's pretty good. And we'll just go ahead then and take a look at the very last one. And that is going to be when we had the cubic asymptote, because we have an x to the fourth over x. Now, this problem does have a little complexity that it has in there, and I will admit that I messed this problem up myself this morning. It's what I've warned you guys about, and I actually made a pretty substantial error. So if I drop the 3, negative 2/3 times 3 is actually going to be negative 2. Making sure that I did that right, drop the 3. This is, I messed that up. That's negative 3/2, isn't it? So let's fix that. That's going to be negative 9/2. That's going to be a minus 9/2 here. Then when I multiply those, I get 27/4. And then that 27/4 plus 2 is going to be, let me see, so 27/4 plus 2 should be 35/4, but I don't want to mess that up. That is 35/4. Multiply that by negative 3/2, and then add 5 to that, and I'm going to get negative 65/8. Now, and remember, I'm going to throw that portion away because it doesn't matter. And when I graphed this morning, it just didn't match. And it took me a minute to remember that we had that little rule that said, whenever you divide by something that has a leading coefficient, we have to fix that. So this isn't going to be a 3x cubed. It's going to be a 3/2 x cubed. This is not going to be a 9/2 x squared. It's going to be a 9/4. It's going to be a 35/8 x and a 65/16. Again, keeping in mind that this portion out here was the remainder, so we're throwing that away. So let's see what it looks like in Desmos when we go ahead and take a look at them all together. So here comes Q3. Here is my vertical asymptote at negative 3/2. Here is my strange end behavior asymptote. That's weird, and it should, of course, be dotted. Somehow this graph has to be modeling that. So what happens when I turn it on? And again, it's probably hard to see it together, but that's what the actual graph looks like. So my end behavior asymptote comes along and just skirts the outside of that. And then, of course, the vertical asymptote cuts through the middle. So it is strange that you have this nice curvy asymptote that kicks right through the middle. And that kind of solidifies some of those end behavior asymptotes. And I think that's as far as I will go with this video. And hopefully that's helpful. I will do a separate little video on the last 2 questions on the lecture on 2.6. I think it's questions 4 and 5. All right, see you later. Bye.